A translation is any movement of a shape or an object in a straight line. So look at a square. So this square can move down or up, it can move to the right or to the left, and it can move diagonally. All of those are translations. Any other odd movements, in strange paths, are not really translations. They can't be described easily by a mathematical movement. Let's have a look at this on a piece of graph paper. We usually describe translations by using a vector notation. So we have a movement to the left or the right, and we have a movement up or down, and we write these one over the other. So we differentiate them from ordinary sets of coordinates. The number at the top is how far to the right or to the left the movement is. A positive number goes to the right, a negative number goes to the left. The number at the bottom is how far up or down it's going to move. So let's have a look at this with an example. Here we have a rectangle, and we're going to annotate one of those corners so we know which corner we're talking about. And we're going to move this by 4 and 3. So the 4 is a plus 4, so it moves to the right by 4 places. And we can see there that the top left-hand corner that we marked has moved 4 units to the right. Let's mark the corner again, the new version, and then we're going to move it 3 units up. And we can see that the top left corner has moved up by 3 units, and there's our translation, 4, 3. Let's do another one here, -2, -10. So we said that minus numbers means we go left with the top number, and it means with the bottom number we go downwards. So let's take the green square, 2 spaces to the left, that's the -2, and then 10 spaces down, that's the -10. And so we can see that's moved the top left hand corner from the point 10, 7 where it was to 8, -3. And if you look at that, you could take off the 2 and the 10 and from the original positioning and get to where it's moved to. So a translation is a very straightforward movement. It's a movement to the left or the right and a movement up or down, or a combination of the two of those things. And we denote our translations by using vector notation, which is very, very similar to a set of coordinates, but we write the vectors one on top of each other to differentiate them from those ordinary sets of coordinates so we don't get confused, because we're going to use the two things in conjunction with each other at certain times.